As we do an example from 3.4, what we're doing is we're analyzing equations of polynomial functions and sketching the graphs from those equations. So we're not going to use a graphing calculator. We're not going to do a table of values just to kind of plot points and try and connect the lines with a line or a curve. We're going to actually look for specific aspects of the equation, and then we're going to sketch the graph. So that's kind of where we're going. In calculus, this is pre-calculus. In calculus, there's a huge section in Calculus 30 called curve sketching. And we use all of this stuff plus other calculus aspects, calculus skills that we kind of analyze these functions. And we also use some calculus to get a very detailed sketch of a curve. So this is really building into something that you're going to be doing in Calculus 30 directly. So if we look at C, what we have to do is we want to factor this because we need to, well, we could write down the leading coefficient, I guess. That we could do that first, okay? So over here I have just some cues here of the things we're going to be looking for. So the leading coefficient is what? And it's easy to see here. This is the leading term. It's a degree 3, and the leading coefficient is what? -2. Everybody see that? Okay. All right, the y-intercept, we can actually, we don't have to do anything to this equation to notice the y-intercept. It is what? That's -4 because the constant is -4 there. Everybody see that? Okay. So the zeros and the multiplicity, we're going to have to factor this one, okay? So, can we factor this by sight? Well, it's not a quadratic, it's a cubic. So we might be able to factor this by sight, but I think we should probably go through the process that we've been learning. So let's check, you know, x minus 1, x plus 1, and so on. Factors of 4, we'll start with those, right, and so on. So if we do, well, this is v, so let's do v of 1. What does v of 1 give us? That is -2 plus 6 minus 4. Oh, that looks really good, actually. -2 minus 4 is -6 plus 6. So that gives us 0. Everyone see that? So I put in plus 1. That means x minus 1 is a factor. All right. So we can continue on and do synthetic division, maybe. So let's put in 1 here, and let's do the elongated L. Let's put our coefficients. So I have -2. There's no x squared term, so I have to put a 0 there for the x squared term. 6 and minus 4. Does that look good to you guys? Put a little box there. This is going to be the remainder, and this should be 0, right? This should be 0. So let's hope that that's 0, then we've done everything correct so far. So synthetic division, real quick, drop that down. Multiply, add, multiply, add, multiply, add. Awesome, we get 0 at the end, so that's great. So we understand that we have x minus 1 as a factor, and I'll write that down here. And I also have -2x squared minus 2x plus 4. Does that look good? All right, I can take a 2 out. You can take a 2 out as a constant. Actually, let's take a -2. And then I have in here, this is positive x squared plus x minus 2. And then you get to a little quadratic there that might be a little bit easier to factor. So can we factor that? Can we figure that out? Plus 2 minus 1. So looks like we can factor this one to x plus 2 times x minus 1. Does that look good? 2 times -1 is -2. 2 minus 1 is positive 1. So here's our factored version of v, this polynomial. That's the factored version. So what we haven't talked about too much is what happens if we have a constant here. Well, it has nothing to do with the zeros, but it does have something to do with the leading coefficient on the term, right? That's the leading coefficient there. So, all right, well, what are the zeros then? So, just move this down. The zeros are going to be the roots of this equation. So I have x equals what? 1 and -2 and, well, 1 again. Okay, so these are the two zeros right here. And the multiplicity, so let's just rewrite this. -2, v minus 1 And I'm going to do squared here. Oh, v. Why a v? What am I doing? Not a v, that's an x, right? X minus 1. It's going to be squared. Why? Because there's two factors multiplied together. Yeah, you guys see that? So that's going to be written as a squared, because that's important to determine multiplicity. And then x plus 2. Okay, so we're getting pretty close here. Multiplicities on each factor, we have a 2 and a 1. Okay, so we don't have to write that down, but we need to use that. All right, so here we go. We're going to start to sketch now. We've got all this information. This is great. A y-intercept of -4. I'm going to put a point right here because the graph has to go through there, right? It has to go through there. A leading coefficient. Okay, what's the degree? It's 3. So, and the leading coefficient is negative. So that means the end behavior starts up here somewhere and ends down here somewhere. Does that seem to make sense? Remember that odd? Okay, like this. That's odd. And what about our zeros? And, well, the zeros are at -2 and 1. So I have a -2 here and a 1. And what are they going to look like here? Well, at -2, that's a multiplicity of 1. So it looks like it's going to just cross. Now, I'm going to just adjust this arrow here to be over here so that it's more like a real function. See, it's going to cross there. You see that? Okay, still in this quadrant, it's going to go cross -2. It's going to go through this point, so we don't really know where the minimum value is, but we know we have to pass through this point, so let's do that. And then here at x equals +1 for the 0, we have a multiplicity of 2. So what we're going to have to try and do as carefully as we can, and this is going to be tough for me, but we're going to have to come up like this, and then we're just going to have to come and touch that, and then come back down. All right. So that's sort of what the graph looks like. Now we don't know exactly how far it dips down here. It could dip down quite a ways and come back up. I don't really know about this area. And like I say, in calculus, when you get to calculus, we're going to do all this. Actually, we're not going to have to factor actually in multiplicity. We won't use multiplicity all that much because there'll be other calculus things that we're going to do that are going to help us. But we're going to know how far this goes down. We're going to know, where it's concave up and down and all that sort of stuff. So that's coming. Now, if I were to graph this, I'm going to graph this real quickly on Desmos here, and we'll just compare what we've sketched with what this actually is. But this would be how we would go through the process of sketching using all the things that we've learned in this section. Okay? So I'll show you the graph here. So here's the graph over here, and sure enough, it starts in quadrant 2. It has an x-intercept here of -2. It does dip down here and then comes back up through -4. It touches the x-axis again here at x plus 1, and there's the multiplicity of 2, and ends in this quadrant here, quadrant 4. Okay? So it's sort of like our graph, and this would be totally acceptable if you drew one that looked exactly like this. It's got all the important points here and all the important aspects of the roots and behavior and stuff. Okay? Any questions about this at all? Okay, that's start to finish. If you know how to do that, then you'll be set for our quiz tomorrow, and you're in good shape for 3.4. Okay?